Good morning, good evening, good afternoon, all around the world. A very warm welcome from Eberle, Germany, located in Nuremberg. A very warm welcome from my side personally. My name is Fabian Leppich, and I'm glad to present you today a new measurement technology from our side. Which gives you the opportunity for transparency in the low voltage grid. As I explained, my name is Fabian Leppich. I'm working in the field of power quality in the meanwhile 15 years. From my personal thing, I traveled around the world in my last 10 years. To see you all as our partners and also to see which functions are needed to be implemented into power quality devices which we offer. The part today is who is Eberle? Maybe for all of you who don't know us exactly, Eberle GmbH, as I explained, is located in Nuremberg. We have 40 years of experience in the field of measurement and, last but not least, regulation technology. If my family is asking me, what are you doing, Fabian? My answer is always, we are regulating the whole grid in Germany and a lot of grids worldwide. And in the meanwhile, I could also explain to them that we are saving the power quality while we offer and deliver measurement technologies in all voltage levels. We have around 160 employees. We increase our employees year by year because there is a need for it due to the fact of all the issues which are coming into the grid and all the responsibilities which we have to fulfill. We are internationally operating in approximately 65 countries all around the world, and there we are glad to work with our partners, which are maybe also familiar to you. Eberle, what is Eberle doing in case of power quality? We are delivering, or we are a deliverer of the hardware. So we produce the hardware, we produce the software, so the firmware for the hardware, and we produce all here in Germany, in Bavaria. We are also, in the meanwhile, have a huge software department, and we could also deliver the software solution for the whole power quality theme, as well as the other product groups for the regulators, as well as for the earth fault detection relays. And last but not least, we are a service provider. We offer service worldwide, and last but not least, also we could offer in the meanwhile a big advantage from us. We offer also power quality service. What does that mean? We have an own department which gives you the opportunity, which helps you with the recorded measurement data. And I think this is a good thing. And therefore, we say we are a power quality solution provider, certificated according ISO 9001, ISO 14001, which is for the environment, and also last but not least for the critical infrastructure, the ISO certification 27001. due to the fact that, yeah, exactly. Unfortunately, we are in the third world war, I think, in the field of digitalization, and therefore it is a need to have a secure management process here in the company at Eberle. We are awarded for our employees as a top company 2025, and this is a need to get always the right human resources, which helps us to provide all the solutions, so hardware, software, and service with a good experience. We also run some prizes. Top Innovator 2025, and one part of this Top Innovator I would explain at the end of this presentation. We have also a new software solution which is called WebPQ, and therefore we run up the innovation prize. Yeah, which hardware are we delivering? We are offering mobile devices in different solutions, and we are offering also permanently installed devices like PQDS Smart, PQI LV, and PQI DE, as well as the classic platform PQI D. Therefore, yeah. Now coming to the point, what are we seeing worldwide? What have we seen in the past? We see that a general change in the electrical grid is coming and is in an ongoing process. We have to be more efficient in case of CO2 reduction. We have to provide solutions which have a lower weight. We have to have better controllability, and this ends up in the hardware which we equip into the grid. So we are coming from a normal transformer on the right-hand side. You can see here, and we are inserting a lot of power switching supplies. We are changing the light bulbs to LED. We are changing motor drives or drives in general to frequency controlled drives. And yeah, this is the one thing which happens. It is a need that you understand what is happening inside the grid. Therefore, if we change the equipment in the case of consumption, we have always both new technologies and old technologies in the grid. And the old technology is sometimes not able to fulfill the latest requirements, which are coming only by the situation that we add new devices like switching power supplies or switching frequency control drives there. In the electrical grid, we are also changing. So in the case of production, we are putting PV, wind, and so on. We are putting a lot of data centers, a lot of battery storages into the grid, as well as other things. In the grid, it is happening like that we have much huger fluctuation in power. So in general, the electrical energy is decreasing, but the fluctuation is increasing. So we need more stability, or we need more lines, especially here in Europe, especially in Germany. That's clear. But on the other side, we have more consumers, we have more sensitive consumers, I would say, and the whole grid is more actively controlled. We can see that directly on science, on numbers. The situation is like that. In the past, 10 years ago, here in Europe, the regulator has made around 100 influences in the high voltage grid. In the meanwhile, this number increases to 2,500 actively controlling inside the grid. So in general, the whole grid is more complex. So we have an increasing complexity inside the grid, and this is, I think, a trend which is coming worldwide. On our hand side, we get new requirements for measurement technology due to the fact of new consumers and new technologies for production. So in the past, it was always like that we have the so-called classic rectification. So we have, for example, an B6 rectifier which brings AC to DC and with an uncontrolled recharging in the DC link. You can see here on the left-hand side, the sine wave normally is looking like that. So 10 milliseconds, here again 10 milliseconds, and then we have 20 milliseconds. And this sine wave is here an B6 rectifier, or is here have here an uncontrolled recharging of the DC link, and this produces the old harmonics. So what is an old harmonic? An old harmonic, in my opinion, is an sixth harmonic and fifth harmonic, seventh harmonics, in 11th harmonics, and 13th harmonics, and these technology is common. This is coming worldwide. Every measurement technology in the meanwhile have these opportunity to measure until the 40th harmonic. With the new technology which we bring inside the grid, we have a rectification with power factor correction. And what does that mean? We have here not an uncontrolled recharging in the DC link, but we have a controlled recharging in the DC link. And this ends up into a sine wave of the current is looking like that. So we have there often a ripple depending on the grid impedance where these consumer or this also a PV power plant is installed. So we have always a sinusoidal current curve with a high frequency component. And now it has to be clear, as I explained, we have now the situation with a completely new fingerprint of current. This fingerprint of current ends up into a fingerprint of the voltage. And this fingerprint of voltage see all the consumers, all the prosumers in the near of these equipment. And it can be that this equipment is not tested with the higher frequency due to the fact that at the in the last years there were no EMV norm for or EMC standard for threshold values for it. Now we have threshold values, and these threshold values have to be controlled. And these threshold values could only be controlled with technologies who could measure these so-called superharmonics. So we have, for example, wind farms 2 until 9 kilohertz can be only recorded, can be only controlled with a new technology of measurements, and this is all our devices, PQI LV for the low voltage grid, PQI-DA Smart, as well as PQI-DE can have these functionality. So new technologies in the grid, new prosumers, new consumers have new fingerprints, and the typical switching frequency will be higher, and the measurement technology which we have to bring into the grid must be also able to control these higher limits due to the fact that we get more of these consumers and prosumers into the grid. I think this is a really easy to understand and really easy to handle thing. We, in our thinking, have always the opportunity to extend these measurement technology via a license, via an extra license. Why? Because we want to reach the price of higher of comparable measurement technologies, but we want to give you the flexibility to measure, if needed, also the higher switching frequencies coming with the new mobiles, PV power plants, and so on. So new technologies require new and sustainable measurement concepts in our point of view. So we have, and also due to the fact that in case of different measurement technology, different different measuring points, we have also different solutions. In case of measuring at the household, if there is an error inside the household at the point of common coupling, or also in the industry grid, maybe at the end of the line of the industry grid, it is always a good solution to measure these in the depth of the grid, to measure these issues directly where the error happens with the mobile devices. If you want to add, if you can combine the permanent monitoring system for predictive maintenance, it's good to have one software solution, and therefore we provide a software solution which is called WebPQ. At all voltage level, this idea is possible. So first of all, you can measure with a mobile device. Maybe you can see there is an extension sometimes, and there are higher values in case of supraharmonics. You will have then the opportunity to install therefore a permanent monitoring system to control these values in a permanent way for predictive maintenance. So the idea is not to bring everywhere a permanent monitoring system, but the solution provider like Eberle is can deliver both. So on the one hand side, the mobile solutions for every voltage level, and on the other hand side, the permanent monitoring for the predictive maintenance. Which standards can these measurement technology fulfill, or why there is a need to have standards? I think that's clear to all of you. We have different grid standards like EN 50160 in Europe, like IEC 61000-2-2, which is a worldwide GILTI standard. In the industry, we have IEC 61000-2-4 as an industry standard for the low voltage grid. And what happens in the moment is that on the one hand side, at the point of common coupling, the industry company is measuring due to the fact that the problems they have at the point of common coupling are increasing. And on the other hand side, also a lot of energy suppliers will install measurement technologies in the low voltage grid, especially in the low voltage grid. Most of them are completely blind. What does that mean? You even don't know the voltage levels, or you even don't know the harmonics, the normal harmonics. But what you definitely, what I think very less utilities knows is the feeder as well as the low voltage supraharmonics And therefore we provide a solution which is, in our opinion, the right solution, the right choice. The point is here, we have to measure, we have to recognize and counteract trends in a database and to prevent interactions. What was happening to the European grid these days? There was a big blackout, and what we could see is, was in the high voltage grid, not that part of this presentation today, but we could see that we had interactions between different grids, and these interactions have to be monitored while we have a fault recording system inside our devices and together combined with an power quality monitoring system. All devices from us are according an Class A device, edition 3. Why this is a need I have on separate slides. And the point is we have to be sure that we that from internal influences and from external influences we can differ. So every measuring device, which you can see here on the slide, is able to measuring the voltage quality as well as the current quality. And this is, I think, also the right choice for the future. For the low voltage grid, it is a little bit, difficult, because we had to provide here a solution which is really cheap, because we have the number increases in the low voltage grid. This is one thing which lays on my desk in the past, and I had to decide how to can I fulfill both sides. So on the one hand side, we have a high-end measurement technology, Class A. We want to measure supraharmonics and so on. We have to have a lot of numbers of measuring points, and this is one requirement. And on the other hand side, we had another requirement that the whole measuring system must be really cheap, easy to install, and so on. With the PQI-LV, especially for the low voltage grid, we can fulfill this. This is a Class A device, around 1,000 euros. I can explain what is inside. 4 secondary substations, 4 compact transformer stations, for solar parks, for charging parks, data centers, emergency supply systems, as well as many industry applications. So what is the aim of these? Predictive fault detection. With the device, problems in the grid can be detected at an early stage and failures could be avoided. We can optimize the efficiency with the data of the device, clear. So we can identify energy losses and reduce operation costs. The device, due to the fact it is a Class A device, has the opportunity for compliance monitoring for the regulation. So we can ensure compliance with many industry standards and also grid regulations worldwide. The device itself is a data analysis and trend tracking device. So we can identify later then with the software trends for better planning and optimization of the grid. And last but not least, we can protect therefore sensitive devices, sensitive processes in the industry while we measure there. So at the end, we can extend lifetime of such products if we use the data and use maybe also our solution. So our solution, service solution with these data, and we offer you a solution for your grid which helps to extend lifetime of products which you have installed maybe in your industry grid. The PQI-LV is, as I explained, in class A device with very, very high accuracy, smaller than 0.1%. We can measure and also digitalize the low voltage grid with the iSense technology. We have a Modbus master inside, and we are open for third-party products. So it is possible to transfer, maybe if you have intelligent feeders, for example, and these data can be also brought to the PQI-LV. And with the PQI-LV, you have a data logger inside the substation, as well as an RTU, so a real-time unit, which brings the data due to the fact of different protocols to your SCADA system, or also in parallel into our software solution WebPQ. The device have to be very, very easy, because we have to bring it. So the extension is so the numbers of devices are increasing, and this is done via the web server. So we have guided assistance on the web server, and there is no standardization knowledge needed. And this helps you to bring the device into the grid. The security is a main feature of the device. So there are many features. It is on a next on another slide coming with the device, which helps to have the security which your IT department need to have. And last but not least, we have an WireGuard technology for simple and secure connection, also in the depth of the grid, also via 3G, 4G, 5G modem technology. So this helps also to bring the device into the grid. And this tunnel is also used for not secure protocols like Modbus 104 as well as 61850. Yes, the device can measure up to 4 voltage inputs, so have 4 voltage inputs, L1, L2, L3 neutral, as well as 4 current sensor inputs. And for the current sensor inputs, we have 2 opportunities: either very easy to install via Rogowski coils, or also via 350 millivolt input signals. So the new and cheap technology for measuring the current is not 5 amp, 1 amp, but it's a millivolt signal. If you have questions regarding that, please ask us. We will answer you these questions, how to measure the current, and also other questions in this presentation afterwards, directly over our partners, or also directly from my side personally. The device could be synchronized via NTP, because as you have seen also again in Europe with the blackout, there was also again the situation that some disturbance fault recorders doesn't have the right time. And it is a need to have the right time to find issues, I think. And yeah, one big point is also we have the highest installation category for fixed installed units. So it's can be directly connected at the transformer stations, due to the fact it's cut 4 300 volt or cut 3 600 volt. The main function, and which gives you, and which is not able to bring into the database data sheets, is we are always thinking on your processes. What does that mean? This is the point 5. You can bring in the device without any communication, and the device itself is able to record as a black box 130 weeks continuously all the required data. It is up to 800 measures which are needed for EN 5160, which is also needed in case of the most grid codes which are guilty worldwide. And these gives you the opportunity to bring in the device, and afterwards you can organize your IT department to bring the data into maybe our WebPQ, so our software solution, or also to provide the data over other protocols afterwards. And this is a good thing which helps you to make a rollout in your speed, in your IT department speed. What is, and these slides are new to most of you, what is really a need to know thing? We are often asked, why do you provide only Class A devices? And the main thing for me is coming right now, or the main argument. In the meanwhile, worldwide, we have the same situation. We have to measure grid codes, and in the most grid codes, even if it is only in the low voltage grid, the so-called fault right through technology is to all of you, or should be to all of you, a name which you have to know. So if we sort out big plants, if we bring in new technology in case of generation of energy, PV power plants, wind farms, and so on, they all have to run in case of different failures in the grid. What is a failure in the grid? And a failure in the grid could be maybe on one phase, a earth fault, or also a short circuit, or whatever. What does the windmill have to bring? The windmill in that situation must bring in to the grid some power. And which power? Reactive power to support the voltage stability. And worldwide, we have therefore the so-called fault right through curves. So we have a sketch where it is defined when must the windmill bring in reactive power, when must the windmill be stable and stabilize the grid or the PV power plant. And all of these fault right through curves have the same requirement. They want to have a time of a dip and the depth of a dip. If you have now different measurement technology, where in the data sheet it is written we have an accuracy 0.1% maybe, or if it is in Class S device, it is not said how these dips have to be measured. And now one formula with three different methods, what can happen? So we have a signal here, like here with a small dip, and three different measurement methods. And these three different measurement methods you will see will end up into different results. So with one method, we have 20 milliseconds true RMS value. We calculate, so we have here 230 volts. With the method 2, we jump into it 10 milliseconds later. We have at the first point true RMS 230 volt. With method 3, we are shifting only not 20 milliseconds, but only 10 milliseconds, and therefore we have here 2 points, 230 volts and 230 volts, due to the fact that we shift. On the next slide, we are here. We have here again 230 volts. Here we have shifted 10 milliseconds. We are here at 182 volts. And with method 3, we have here 230 volts and now here 182 volts. Coming to the next point, measuring point, zero crossings, 150 volt, 182 volts. Here again, 115 volt and 182 volts, and so on and so on. The point is here, as you could see, different methods have different results. So in method 1, we have the result that this dip was 20 milliseconds, 115 volt. With the method 2, we have 40 milliseconds, 182 volt. With the method 3, we have a shift of always 10 milliseconds. We have 182 volt, 115 volt, and then afterwards 182 volt. And the longest point is here 10 milliseconds. 10 milliseconds. And the question is here, what is guilty for fault right through? And guilty for fault right through could only be a measurement result which is explained, which is defined. And therefore, we provide only Class A devices due to the fact that the size of the time window, the sliding window, and the position of the window is a need to know thing, and the result is not really dependent on the accuracy. Yes, a little bit, clear, but the main thing is we have to define the measurement technology, how the measurements have to be calculated. And in the Class A, it is always like that the voltage and the current as well is measured over a period, starting with a zero crossing of the fundamental and is refreshed in every half period. This is only one small thing which gives you the feeling why there is a need to have a Class A device and not to use any other devices. Due to the fact that at the end of the day, you are discussing with maybe a wind farm producer, with a PV power plant user, and you have to argue. And with a reliable measurement technology, you can argue. This is, I think, clear on this slide mentioned, and only one small thing which is defined here. There are many other values which are completely defined and also defined over the external influences like temperature, like the frequency. Because if you are measuring maybe over zero crossings, it's clear that the frequency will also influence your measurement results, and this have to be also defined. And there are many measurement technologies used worldwide, unfortunately, which gives you different results at the same installation point, installation place, and the failure which you get is not coming over the accuracy. The failure is coming always over the measurement technology, how the measures have been calculated. I'm born in the 80s, and before we had the same discussion with true RMS, I would say. So non-true RMS measurement technology and true RMS measurement technology is a little bit different, I know, but from the situation we are right now here as well, due to the fact Class A device or not Class A device. Coming to a next big advantage of the devices, we bring with the devices, and believe me, this is the main point of the dev department in the meanwhile, IT security. We have to have on the device itself, in the critical infrastructure, and user rights management with role-based access. So every user is have to be controlled regarding its rights on the system, and this should be manageable via group policies. It protects the devices against unauthorized access, and also it gives you the opportunity to make the data secure. Radius is needed due to the fact that no one wants to bring in all the users on the device itself by writing usernames and passwords into the device. It has to be centralized, organized, and therefore we provide also Radius client on the device for central user rights administration, and it is a need that we also provide here a fallback level. Audition logging, a next point, which is also coming in Europe again, with now the ongoing discussion and now the Cyber Resilience Act here in Europe. And I know also from our partners worldwide that the discussions are also in the other countries like that, everything, every change which is done on the device have to be logged inside the device. So if you log into the device, it has to be logged. If you try to make that continuously, the device must have a brute force detection system, and to stop these wrong or to stop these attacks. The firmware must be signed, the data transmission must be encrypted, and one big point is here also we have to make our development secure, so we have to have a certified development and release process. We have to test always against the main security issue. Every morning I wake up, I get an information how the firmware is. This is the new way to do that, using there also external tools. The technology which we bring into the grid, into the depth of the grid, must be able must have open interfaces. This is the main point, I would say. So the device can be delivered over 61, can be delivered data for the SCADA systems over 61850, over 104, as well as Modbus RTU TCP. We have a REST API which is openly, so you can also bring in the data over REST API via HTTPS. The device is on Modbus master, and yeah, MQTT, we are now at the end of the dev process, so a really new technology for providing data, because the data for from such device is needed in the centralized data lakes in the utilities, as well as maybe also in industry companies. We have applications in the industry as well, where we bring in the data over MQTT, that the industry company is able to reduce their energy costs and is able to make certifications for energy losses and so on. So I think in general it has to be clear that the device must have many interfaces for many different applications. An application which is able with the device is not only recording, it can be also used maybe for regulation. So the data is coming maybe over 61850, maybe the frequency or the voltage in 10 millisecond or 200 millisecond values, and this data could be used for a centralized regulation system, maybe in case of grid injections there. What does the device do? In general, data logging. A data logging in 7 different intervals is possible. So in 10-minute main interval for statistical evaluation, load analysis, and fault location, we have over 3,800 measures like frequency, voltages, face-to-face voltages, face-to-line voltages. And we have also here the so-called extreme values, not only for the voltages, but also for the currencies, power, harmonics, and all these stuff. The frequency in case of EN 5160, as well as other regulation standards, is able to be recorded over the 10-second interval, 2-hour interval, 50-minute or n-minute interval for energy measurement. Accuracy check of energy meters is an application, therefore, as well as yes, the regulation in case of industry. And we have faster intervals, 200 millisecond, 3-second, n-second interval for SCADA, and as well as for the fast data storage. Up to 3,000 measures are possible here in each interval. Who is interested, please ask us if the measure you want to have, if the measure you want to need or you need is possible with the device. Just give us a short questions afterwards. Here an example: frequency combined with voltage, current, harmonics, power, energy, and the 2-hour flicker values. And we, as I explained, we also can provide the extreme values based on 10 milliseconds or based on 200 milliseconds in the interval. Here's an example of 1 month at my household where I directly see what was the lowest voltage level, and the lowest voltage level was here this level. And as you can see here, this level is around 150 volt, and this is normal and general here in the meanwhile in Germany, and I think also common in other countries, that we often have these so-called dips, and these dips can be also controlled over these extreme values. And so it is always clear how the voltage, how the harmonics were, and not only at a stable point, but also at an point where an PV power plant or an EV is charging at the beginning or at the end, so not at the stable point. If you want to go deeper into the data, we have a fault recorder inside the system. So you can up to a recorder length, and if something happens, if a dip occurs, you can directly monitor and directly record the fault. And this fault can be triggered by many opportunities, by many different triggers. So voltage, threshold, so upper threshold, lower threshold, step, current, and so-called transient trigger, and a so-called envelope trigger. So if a transient happens, we can record this transient. The frequency Rockoff, rate of change of frequency, also in this price class is possible with the device, with the PQILV. And we have an manual trigger, as well as trigger over protocol, so Modbus or 61850. Yeah, coming to an application which is quite next to my house. Here we installed on PQILV, and we have 3 different applications. So one device, 3 different applications. It was installed for load, energy, and power analysis in normal operation. So no power quality, only load, energy, and power analysis in normal operation. In case of an error or something happens in the tunnel, maybe the smoke extraction system runs up, the system is automatically recording and snapshot in case of a fault recorder in the event of a power failure, because an UPS system must run up, and there are many issues happened in this tunnel in the past, and the German Autobahn GmbH knows about the situation, that it could be unstable, and they want to have an exact snapshot of the true RMS as well as the oscilloscope picture in case of this failure. And last but not least, the smoke extraction system has an EMC filter, so it is not it is a frequency converter before, and there is a filter before, and it is clear that also the filter must be monitored, because the filter could have failures. So the system can be also used for monitoring of EMC filters. Yeah, at the secondary substation or the distribution substation, we have many applications in the meanwhile with the device. So we can monitor the substation for power quality. So is the power quality reached in the substation? Because if the power quality is not reached in the substation, it's clear at the depth of the grid you will have completely worse results. So it is good to have a monitoring device at the substation. We can have fault recording at the substation, and we can monitoring the substation with the supra harmonics. But with just an insertion of all these protocols which I have mentioned, we have now an ideal head unit for supplying measured values for network controlling and the feeder. So we can monitor as well as the feeders with our iSense technology. We can store the data. The data can be also transferred via the open protocols, via 104 MQTT to SCADA systems for having better controls. The iSense technology, we sold out last year a lot of such devices, is really easy to install and to integrate into the substation if you have already installed substations with no measurement technology. It is therefore an inexpensive and reliable technology. Due to the fact it is coming with Rogowski coils, you must not switch the substation off. It is high compatible. So if you have already PQI Smarts, PQI DE, as well as PQI LV, you can use these technology to bring the data into their devices. Therefore, it is compatible and independent of the hardware. And last but not least, it is protecting the low voltage transformer, more or less, I would say, the fuse of these transformers. Here's some examples from installation. Yeah, it is looking like a little bit crazy here, but this is an old substation here. So installed, I think, in the 70s. And now we have to digitalize the substation. And as you can see, it is really easy in case of a daisy chain. So the iSense is directly installed at the cable. The Rogowski coils is directly installed at the cable, L1, L2, L3, or as well possible neutral. This is no must in my opinion. And with these RJ45 plug, you can daisy chain these technology through the whole substation, and the end you will bring into our device, bring it into it, and now the whole substation is is digitalized. The point here, or the main thing, is the easy to install thing. I have by my own installed many substations with this technology, and I could say I need approximately, I would say, 1 hour to bring in all these feeders, depending on the number of feeders, and then it is I think a good solution. Here some more pictures that you can see. It could be also looking, in my opinion, really glad. The PQI LV, as well as also the other devices from us, has a web server. For what is the web server needed? For the commissioning. So it is possible to make the commissioning very easy without installing a software on your PC, which is yeah, unfortunately for us, and also unfortunately for you, mostly not possible anymore due to yeah, your own security regulations in case of certifications worldwide. For the live data view, so you can have here online visualization of the data of the feeders, and yeah, the web server is also needed and often used for applications which we always call black box. We install a lot of such devices, maybe in the depths of the grid, and if nothing happens, no one is interested into the data because there is no regress coming to the utility. But if something happens, you can directly connect to the server, to the web server. You can directly read out the data via ComTrade format without a need of an extra software and so on, and bring these data into your system, bring this data into our system, maybe WebPQ, which is a centralized database system from us. But there is no need to use our system, therefore. Yeah, so it gives you more opportunities, and also PV power plants are always organized in case of that you don't have access and so on, and this helps this web server technology to get these data really easy. And parameterization and device management is also possible. So the complete parameterization could be also managed by the web server, as well as the users and rights management. Yeah, I'm in time. Great. WebPQ is, as I explained, a new software solution from us. We switch right now the software. Maybe there are some customers from you which have software from us which is called WinPQ. Now we provide a solution which is called WebPQ. The WebPQ is an on-premise, don't mix it up, is an on-premise installation, so it is located on your server technology, on your IT department, but it is made for the future, like that we are open for new technologies like Kubernetes, like cloud services, and so on. So we call the software WebPQ with this cloud, but it must not run in the cloud. It can be also run in your system. Believe me, just as a Windows service, not that issue. It is a centralized system which continuously hold the connection to the devices, maybe in the low voltage grid, maybe in the high voltage grid, and combines all the grids together in one database to find issues, to find things which is coming to the grid. We have seen that here in Europe, and to have the opportunity to provide the data in one system. It is device independent and also platform independent. So the main functions of the software is not only the analysis and reporting functionality, but also the efficient device and fleet management. Because I think it's clear also worldwide we have the issue with human resources in the field of electrical engineers. In Europe, every country is telling us it. We don't have the human resources to digitalize maybe the grid. And therefore, the solution for the future must be able to make processes which you have to fulfill in a really easy way. And therefore, it is a need to have an efficient device and fleet management. We have, for example, an opportunity of a fleet management, simultaneous rollout of templates of many parameters, simultaneous firmware upgrade via our technology over the air. The software must run in the background and must automatically monitor the grid and only inform, so event-based information you have to you get out of the system with the software, and according the power quality limits, and this could be also fulfilled. We have an optimized analysis and reports inside these software. So over 60 standard and grid codes are inside. So IEC 61000-2-4-2-2. We bring in these standard templates, and it is also possible to bring these templates on different devices. Again, here the security and access management is also done in the via user rights management and RBAC, as well as an LDAP connection is possible for centralized user management. And the main point here, in my opinion, is we have an open and flexible data management. The data which we offer, which we could offer, is has the highest accuracy, the highest reliability, due to the fact that the devices which are installed inside the grid, hopefully the low voltage grid, is according Class A. And this helps us, helps you to fill your data lakes if you are a big utility, but also to maybe energy monitoring systems can access directly over REST API to the data which is needed, not having the interface at the device, but centralized at one point. This gives you the possibility to make the data transfer much more easier, and you don't have to manage many different interfaces. We only have one interface from our database to an external data lake, not to every device. And your IT department is looking for such solutions because they want not to monitor many different interfaces, and the data must be transferred only one times, and not in case of open interfaces in case many times. So I think it will decrease the requirements also in case of speed in the low voltage grid, in case of communication speed in the low voltage grid. Yeah. Now, 5 minutes later, 5 minutes too late maybe, I'm ready. I'm through all these things. I hope I could give you a short introduction. 1 hour is really short to presentate such a system, to presentate such a solution for the low voltage, medium voltage, as well as high voltage grid, because we are coming from high voltage and medium voltage grid. We exactly know what is needed in the low voltage grid, and we could provide here the solutions. It would be really, really glad if you ask us questions, if there are some, and maybe we can also offer you a short presentation directly at your place via our partners or via my colleagues here from sales department, Michael Haupt or Lukas Rappel. It would be great to stay in touch with you. Thank you very much for your time and have a nice day. Bye-bye.